established what became the Office of Scientific Research and Development, or the OSRD. And their stated purpose was to coordinate, supervise, and conduct scientific research on the problems underlying the development, production, and use of mechanisms and devices of warfare. And I promise that's the last thing I'm going to read off of a slide, because everybody hates being read to. Some of the OSRD projects included radar, the bazooka, anti-tank rockets, the proximity fuse, of course the Manhattan Project, the atomic bomb, and many, many others. It became clear to them that some method of delivering equipment and supplies across unimproved beaches was going to be necessary to support the Allied invasions. So the OSRD worked with Rod Stevens of the famed Sparkman and Stevens yacht design company, and as ugly as the duck is, it's unbelievable that a famed yacht designer who's known for these beautiful, sleek designs actually designed this. They worked with GMC to develop an amphibious version of
our strategy from now on includes for landings on lots of beaches and lots of places. Invasion from the sea. America's fighting a market, so it takes the GI truck, adds a little American ingenuity, and you got that.
So it's basically that GMC truck with an amphibious body on it and everything else you need to do that. Now they had tried this before, about a year before, and Rod Stevens was involved with that, worked with Ford to create an amphibious version of the Jeep, and that's called the Ford GPA. Here's a skeleton view of it, shows some of the mechanics in there. They weren't terribly successful when they were in the water with four guys. If you know what freeboard is, that's the distance between the water and where the water can spill over into the Jeep and sink it was very small. So they didn't do really well in rough water. They built a lot of them sank, and they say there's lots and lots of them in the English Channel and in rivers and things like that. These are really rare and hard to come by. They made about half as many of these as they did ducks, but the ducks just held up so much better. So these are kind of hard to find nowadays. Why is it called a duck? Well, GMC had a standard nomenclature for naming trucks. They used a letter to signify when the first year was developed. C was 1941. C means conventional cab, and if you know Chevys, they were still using C into the 70s and 80s for conventional cab truck, as they were using K for four-wheel drive trucks. And then W for tandem rear axles, and they also had large trucks that had W in the designator. So the CCKW was that 2.5-ton truck you saw, and they made hundreds of thousands of those for the war. The duck was directly based off of CCKW. It was developed a year later. It was still all-wheel drive and tandem rear axles. I kind of think that they picked U as an amphibious body because the word just came out really cool, but it really wasn't, DUCK. It was DUKW. So here's a skeleton view of what the inside of the duck looks like. It's actually a pretty conventional drivetrain with some interesting additions. Engine is pretty standard, plain vanilla thing. It's an inline 6-cylinder gasoline engine, 270 cubic inch. Nothing really special. They built millions of these for civilian trucks. So it had the 6-cylinder engine, a 5-speed transmission with overdrive. And there were 2 transfer cases rather than just one. The first transfer case was for the water propellant. And then that fed into a second transfer case that was for the rear axles. And then you have the rear axles here, you have the drive shaft coming back, leaving the body about right here to drive the propeller, and then there's a power takeoff on the transmission with a set of drive shafts that go back and run. And the duck had a winch on the back because there wasn't a good way to mount one on the front of it. But they had a way to make that more useful. The size of the thing, then the height with the windshield down, a little over 8 feet. This particular diagram shows about 1 in 5 ducks had a machine gun range. So when they went ashore, they had one that had a 50 caliber machine gun on it to kind of clear the beach when they came up. They weigh 13 to 14,000 pounds, depending on what version you have. They are a 2.5 ton, and if you know the old military designations, something that was rated at 2.5 tons meant it would carry 2.5 tons in combat condition. That means over all terrain, anywhere it goes, and then you double that for use on highway. So it can hold, you carry 5,000 pounds anywhere, 10,000 pounds over school roads. And there's some specs on the engine. Maneuverability or lack thereof is about 72 feet turning circle, so it takes a little bit of area that's one of the reasons when I was thinking of bringing it, my duck, as I explained to the people who got here early, the engine is out of it, and I just did not get the thing rebuilt. It's a long story, which I won't tell. But I thought about, well, I'll just bring it in on the trailer and pull it into position, but it's like you need 10 acres, to pull it, and I didn't think there's any way I'd get it in position to be able to do that. It's got excellent grade ascending and descending ability. It was 60% grade. 60.
That's straight up.
That's a good size hill. They'll do about 50 mile an hour on the road and about 7 mile an hour in the water. And because this was an Army development, the Navy gave them a hard time because they talked in mile per hour on the water. The Navy was really upset that they didn't talk about that in knots. But all the manuals show water speed in miles per hour. So let's take a look at some pictures of it, take a quick walk around of the duck. Here's a good restored example. It's sitting somewhere. Unlike the CCKW, which had tandem duals in the rear, they found that in sand and on beaches and in mud, a single tire did much better than any set of duals because the duals would pack mud and stuff in there. So instead of having a 750 by 20 tire that the CCKW had, these had an 1118. So they're a much wider tire, a lot more tilting on it. This shows the rope fenders on there, so in case you bump into something out on the water, try to prevent some damage. The thing, when you had large cargo in there, it was kind of set down in the water, so you'll see the combing here is sits at a little bit of an angle. That would be level in the water when you were loading. We'll take a look at some more specifics here. Here's what it looks like from the top. Very large cargo area in there. It's about 12 foot by 7 foot. And if you're standing in it, standing on the plywood floor there, the sides of it come up to about right here. You've got an engine compartment hatch. Lift that up, the engine's under there. Forward compartment hatch and a rear compartment hatch. And then this is the driver's cockpit. Some pictures of what those look like. This is just another picture of one without the floor in it. Seeing some of the mechanicals at the bottom. View of some of the things on the rear deck. Here's the winch. There's room for a couple of jerry cans here. There's the anchor sits in here, spare tire, fuel tanks underneath there. And interestingly, they had markings on the back so you could tell how much you would put in. So if you were in really rough seas, you were only supposed to load it until you got to this line. A little smoother sea there. If it was really calm water, you could load it up until it then sank into the water up to that line.
Now, was the winch manually operated? Not the winch, the anchor. Was the anchor manually operated or was it operated by the winch?
The instructions had you taking and hooking it to the winch because it's a heavy beast. And by the time you got it on the end of the cable, and it's actually, there's no rope with it, you're supposed to use it with the winch. So you just drop it down there and pick it back up. It's a good size damn winch. Sitting down on the ground, probably see how long it's found early on that if they covered the wheel wells with these panels and they just pin in place, 4 places, they picked up about a mile per hour out on water. Not having the water kicked into the wheel wells from that. So if you see ducts like at duct tours, most of those have been thrown away. But that's the way they were originally set up with the wheel wells on them.
Do the wheels run when you're in water or always?
You have your choice. Normally, under normal operations, you would shut the wheels off. If you do have a propeller failure, though, the thing will make about 1.5 miles per hour just running the tires with the tread on it. It will make forward progress with it. Yeah. And also, steering, you turn in the front wheels in 6-wheel drive, it'll actually steer a little bit. Here's the cockpit of the duck. Kind of a standard World War II main panel here. We have the speedometer here, water temperature, oil pressure, fuel gauge, and ammeter. Standard transmission, of course, foot starter. You've got a 5-speed transmission with a really funky shift pattern. They wanted an overdrive transmission because they wanted this to be able to do 50 at low. And with 91 horsepower, that's kind of a trick with a 20,000-pound vehicle loaded. But they did make it an overdrive, so to shift it, you've got a 5-speed. First is here, and then you come up to second, to third, to fourth, fifth. Well, the reason they did that, they had to take a normal third gear, they took the gears out and swapped them to make them an overdrive rather than an underdrive. So your overdrive is actually where your third would be in a sixth.
So, a top loader or would it just a plate loader or shift like?
No shift linkage, just top loader, right in the top. Emergency brake, pretty typical for there. It's a brake drum on the back of the transfer case. You have the standard, your high and low range on your transfer case and your front wheel engagement, disengagement here. This shift lever here, and we'll look at that more, that's for the winch, and this one is for the water pump. And then there's a whole bunch of instruction plates, and when we're done, I've got some of them laid out over there you can take a look at.
Does this have a bilge pump?
It had mini bilge pumps actually.
That's one there.
And that was the most important thing when we talk about ducks in the news in the last 10 or 20 years. Most of the discussion centers around those bilge pumps. What else do we have here? These are air pressure, compressed air run, which will thank you. Had about a 1-inch thick windshield. The early ones had a normal thickness, but with the spray coming over the top, they found they had to have inch thick glass to keep it from busting in. There's some spare drain plugs in the bottom. There's 4 big drain plugs you can pull out when you wash the thing and to drain out a large amount of water from it. Wooden steering wheel. And we'll look at some detailed pictures of a lot of this other stuff. This is just another picture of the cockpit showing the standard compass that would have been installed. Because at night, you gotta they tell the compass bearing for the shore, and otherwise you couldn't see where shore was. You just had to trust the compass. And then the spotlight. This is just a shot of from the front compartment looking back into the cargo compartment, and this has the top bows and tarpaulin installed here. So you can fully enclose that in rough seas. So as the water would ship over, it would just hit the canvas and run out rather than coming inside. Again, the engine's pretty plain vanilla, 270 cubic inch inline 6. Nothing really spectacular there. The only interesting thing of it is, because a lot of the ducts were equipped with radio, they had to be radio suppressed. In other words, you remember old cars with the AM radios, and you get a bad spark plug wire, and you can hardly hear the radio. Well, they completely encased the ignition system in this sheet metal cover here. It's got a bottom, and the coil, distributor, spark plugs, and all that are guarded when you've got a leaky hood seal, and sometimes these things actually nosedive into the water if you go in fast down a steep ramp. They're designed, the whole front end will submerge, and they're very buoyant, so they'll pop right back up. But sometimes, if the seal wasn't really good, it splashed spray water for a moment on the engine. But they found, hey, with this shield, it doesn't fill the engine anymore because it keeps the salt water off the high voltage.
Did they have a raised air intake or?
They do. Of course, the air cleaner there is underneath the hood. And I'll show you the air flow with some photos here because you think, well, how did they cool? I mean, the radiator's out front, and how do you keep the thing cool? And how do you get air to the engine? So
What kind of carburetor is that?
that's a Zenith.
Zenith, I thought so, okay.
The early ones had a zinc cast one, like the trucks did, and then mine, which is a 45, and a lot of the newer ones, all 45, the newer one, they started making them out of cast iron because these were subject to so much vibration and being tossed around with the zinc would crack. So mine is actually a cast iron carburetor. So you asked about the engine cooling. That little compartment between the driver's cockpit and the cargo area back here, there's this little walkway with this grating on here. That's actually the air intake for the engine. The engine has a reverse flow fan on it. The fan actually blows air from the engine side through the radiator forward. So if we look back at the air would come in through the floor grids here. The fan on the back would draw the air under the driver's compartment, around the engine, push through the radiator, and then the air, this was a sealed bulkhead around the radiator. It was blown into the forward compartment, and then there was ductwork along the side of the engine. The air would take a U-turn, and then come along down the sides to these air discharges, which is the other picture there. Right there. So that's the air discharge. So it took a long, circuitous route to get in there, and cooling was, you had to have the cooling system at 100% because you're maximum, you're out of the water, you're running the pedal all the way down in second gear to get the most speed out of the thing. If you look in there, the exhaust manifolds would be glowing orange, when you're out of the water, so they needed a lot of air to keep it in. There was also provisions for hand cranking it when you were out on the water because it's kind of hard to get a jump start, when you're out in the water somewhere. So on the water propeller drive shaft, there's a path, you flip it open, and there's a tool that just sits there in a little bracket. You pick that up and you can stick it in that and you can turn the engine over and crank it over. This is a close-up of the winch control lever. We looked at the cockpit. It's actually a 2-speed winch with reverse. Low for heavy pulling, high for pulling in the cable under light load, and that is run by a standard power takeoff on the side of the winch. And then it just shows the operation of the winch in the back. Now they put the winch, and I hope I've got pictures of you to see that. The winch was in the back because they couldn't put it on the front, but they did make provisions for being able to pull from the front. There is this little access plate right here under the dash. There's another one at the rear of the cargo area. So if you needed to pull typically from the front to pull yourself forward, you took the winch cable, you took those 2 access panels off, you run the cable through, run it through there, and then on the bow you can see this top up there. You run it through that, and then you can winch typically forward with the cable running right by your head. And you need you to winch. No, that's not such a good idea. if you look at it, you know, it's like, they come up with the idea, within like 45 days they have a prototype, and then they worked on improvements in that. For some reason,
Was there a lot of iterations and through the war, a lot of improvements?
With the wrong tire pressure and to the track, as this demonstration will clearly show. The duck on the left has tire pressure for road driving, the one on the right for sand. The hard tires make narrow, deep tracks, while the deflated tires play out like a downward push, giving good traction. The driver with the hard tires might have gotten through on level ground, but now he's in a spot with his wheels digging in deep.
so I already, you know, I accidentally showed my next slide there, but there was, from early on, they had an air compressor on the dock with an air hose, so you could get out and put the tire pressure down, and then when you got back on road, jump back out and fill them back up. Well, when the Humvee came out back in the, when did that come out? 70s or 80s? I guess 80s. There was big hype that it had central tire inflation. You could do it from the driver's seat. And they made it seem like it was a brand new invention. Well, the duck had a central tire inflation. After about the first 2,000 were made, they determined that it's not good to have guys stop on the beach and readjust the tire and get out and try to do that. So they developed the central tire inflation pressure system. There's an air compressor run off the front of the crankshaft. When I just took my radiator in to get it rebuilt back in like June. And when I told them there is a hole in the radiator, but I don't want you to fix it, there's actually a hole through the radiator so that the drive shaft, the air compressor, can pass through. So changing a fan belt is not an easy task. What they would recommend that the drivers do is you take a spare fan belt and you put it on when you put the new one on, and then you tie it up so that it was already, you know, around the drive shaft. It is water cooled with the engine cooling system. There's cooling lines there, and then has its own crankcase for oil. This is how they did the central tire inflation. There was a hub. This hub on the outside stays stationary, held in place by these bars, which also have the inflation hose in there. And then there's a short hose that goes into the valve stem. And all six have those, and of course the front will rotate in another direction also, so that you can steer the front tires. Next to the driver, this is would be, if I'm sitting like this is the water propeller shifter. Those 6 valves there are the 6 valves for the tires. So if you had a airline brake or something like that, you could shut the air off to that particular tire. Normally you leave those on. Boy, that's not showing up really well with the bright the thing is, but here on the auxiliary panel, there is a tachometer, which most military vehicles did not have. There's a tank tire pressure, or not tire pressure, air tank pressure gauge. And then if you want to hold up there was a tire pressure gauge that when you use this lever right here would do the inflation. And it's marked right on there, sand and coral and highway. So if you were on coral, you had to have a certain amount of air pressure. If you were in sand or mud, it's marked right on there where you can adjust the tire pressure right there. Some of the green features, of course, you've got the propeller, and we've got a spare propeller sitting back there. If you do not have back problems, you're welcome to lean over and try to pick the thing up. My duck, the one that's on there, that's actually a bronze propeller. This is a later cast iron propeller, and it's a beast. It's a beast. And now you can easily see where the 14,000 pounds came from when you start picking up stuff from the dock here. You've got the rudder in the back, and the rudder is tied in with the steering wheel. So if you follow a duck down the road, when you turn corners on the road, the rudder goes and when you're in the water, steering up the water, the front tires are still going back. So they operate in tandem with one another. I always ask this because I've never gotten an answer. I've been in the military vehicles for 20, 30 years. Some of the World War II vehicles on the pintle hitch had this little thing hanging down. And we have no idea what that whole thing that's cast as part of it, why that's there. So if any of you know, come up and talk to me afterwards. Because nobody seems to know why they would waste the cast iron tube or cast steel to put that whole tube on there. Now, I said that after the transmission, you got the first transfer cases for the water propeller. And that engages or disengages the water propeller going back and forth. The thing is designed to operate in second gear out on the water. That's the way it's all geared together to spin the propeller fairly slow. It's a good sized propeller on that. Well, they found out that when you try to reverse, the propeller is moving really slow. So the later ones have an overdrive in the water propeller transfer case. So if you'll normally operate engage it by going to standard, this shows the shift pattern. Neutral in the middle, that means the propeller's not turning. Standard, but if you need to operate in reverse, you put the transmission in reverse so that the propeller arc goes the opposite way, but then you move this down into overdrive so the propeller will turn at a reasonable speed. So there's a lot of things to remember when you're operating. In the hull there were 4 bronze drain valves. Andy, if you could hold that up. That's showing that's the inside, that's the outside. You can see below the hull. So you could drain the hull just by walking around, and at the corners of the cargo compartment and at the front of the driver's compartment, you could twist those. And as soon as you came ashore, that was the first thing you did, is send your assistant driver to go open those up and drain any excess water out of the hull. They asked about bilge pumps. There are actually 2 bilge pumps. This is one of 4 bilge pump intakes. There is what's called a dual pump. Runs off of the propeller dry shaft, and it'll pump about 150 gallons per minute. And you've got a selector. You can select any one of the 4 compartments to pump out. So that's how you would kind of take turns pumping out different areas, and this is the strainer to pick up for.
So it was one central pump before.
Right. That was the Gould pump. And then you had the Higgins pump, which was the OHO pump. And these would pump about 350 gallons a minute. We're talking about like fire truck stuff. And this just sits down in here with an intake about that far off the floor. That runs all the time with the propeller. And if you took a 3-inch shell to the side of it, that'll keep up with it. That'll keep the fluid flowing. So there's a couple places where the dock is susceptible to damage that let water come in, but the Higgins was put in there so that it'll keep up. And underneath that air discharge is where there's a little cover there where the water gets discharged. And then if things got really bad, there was a hand bilge pump up on the hood that should stick down in there, and they say you can pump 30 gallons a minute. I would like to see the guy. Maybe I wouldn't want to see the guy if we get 30 gallons a minute out of that. Another picture of the windshield. When you would get into surf, and you saw that one video how they were getting in pretty heavy water, there's a surfboard that you would put up in heavy water to try to break some of that water spray from getting in the windshield. So here's a quick, this is a display up in Branson. Kind of an interesting thing. It just shows all the mechanicals going on. You've got the tire pump in the front, drive shaft going through the radiators. Pretty standard engine with the enclosed ignition system there. 5-speed transmission, short drive shaft, water propeller transfer case. cable driven. The rudder was all cable driven. The ducts, of course, had cannon rear axles, and there were 2 drive shafts. There's 2 outputs to the rear on the transfer case, so it's got a separate drive shaft for each one of their rear axles. I said I wouldn't read another one, so I'll just paraphrase it. So one of the reasons we were successful in World War II was our ability to supply the troops. That was a little excerpt from the Battle of the Bulge, and just showing that we were flying fresh cakes across the Atlantic to a private, and the Germans just couldn't believe that. My dad always told us from when we were very little about that. He was a transport motor sergeant in World War II, and he's the one that taught me about ducks. It was real little, I fell in love with it. Then we got to go to Wisconsin Dells and go on. So everybody tells me when I start talking about ducks, I turn into that 2-year-old kid again. But he always said we won World War II because we were the firstest with the mostest.
Is to bring in the vital supplies of the various services.
So they could put the duck in either over because there were lifting rings on it, or you could drive them right straight off the MST. And that's how they would get them from
Working in artillery, 2 ducks work in a team. While advancing toward the beach, the trails of the gun are split, enable firing from the duck if necessary. 1 duck carries the gun and guides the gun crew, plus emergency ammunition. While the other duck with the A-frame and radar carries the rest of the gun crew and the bulk of the ammunition. The approved combat load on each duck is about 7,500 pounds. As the 2 ducks arrive on the beach,
I won't play the whole video for you, it's kind of long, but basically some of the ducks had this A-frame on the back of it, that every 5 ducks would have that so they could unload each other.
meanwhile the A-frame is raised into a lifting position, simultaneously to which control lever in the driver's compartment.
So that's run off a winch, and it becomes a little crane right there on the beach, and they can unload the other ducks.
By this time, the crew of the gun duck has fastened.
So this shows just some pictures here, shows one being launched from ship side. That's what those hooks that are angled on the corners are for. That's so you can lower them into the water. And then just some shots. I believe this is in Anzio of the Mediterranean. This is in Great Britain as they're loading up. This is coming ashore at one of the landings at D-Day in Normandy. Showing another one getting supplies and kind of heavy water there. They did really well in heavy water. I mean, between the zilch pump and the fact that they were fairly buoyant, they did a good job. This is another one just inland from Normandy. Duck train, hauling in and hauling out. This is in another one, Holland. They had just brought a bunch across the river. They were bringing troops across the river. They did a lot of interesting things, trying to take 2 ducks, and I mean they actually did it. This is what they call a dry ferry. Put 2 ducks together and put something large. A Jeep, you could just sit in the back of the duck. It's plenty big to hold the Jeep. This shows a 2.5-ton JMC on what's called a dry ferry. And they also did it with tanks. They took it, they said the captain said it was a Sherman tank, but it's not a Sherman tank. They would take the tank and have it mostly submerged, so take most of the weight off of it. And then the 2 ducks would provide enough extra buoyancy that they could take it ashore, all the, and that was all the way through. And they did it with airplanes, and GMC spent a lot of money on advertising in civilian publications, and I got to put them back here, because they were pretty darn proud of them. They even mounted a fire truck liner on one at D-Day, so they didn't end up using it, but the thought was that they could not get scaled up the rock cliffs. They could pull this up and raise the 100-foot ladder and just climb up on the fire.
On June 12th, 6 days after D-Day began, Prime Minister Winston Churchill became the first of 3 important passengers to arrive on Normandy beaches via land. Next, it was the future President of France, General Charles de Gaulle. His first step onto the newly liberated soil of France remains a truly historic moment. It was hardly a dignified entrance, but thanks to the duck, at least he kept his feet dry.
You notice they put a ladder up after he gets
2
off.
days later, the duck again helped make history.
On the 16th of June, just 10 days after the opening of the invasion, His Majesty King George VI paid a visit to the fighting front in Normandy. The King went ashore in one of the now famous amphibious vehicles known as ducks.
The duck had finally achieved the ultimate status. It was literally fit for a king.
I get that ladder.
Well, of course, Eisenhower and all of them came ashore on ducks. It was just the easiest way to get them. Some quick facts: over 21,000 ducks were produced during their production. They're used in virtually every amphibious assault. And in Normandy, they carried over 18 million tons over a 90-day period because there were no ports available. Kind of an astonishing number when you think about it. General Eisenhower, Supreme Allied Commander, said that that was the most valuable piece of equipment in the United States during the war. And Rod Stevens, the designer, had something else to say about it. They were used again in Korea quite extensively, and really they weren't taken out of service until well into Vietnam. This is actually landing or taking troops into somewhere in Vietnam. I can't remember the name of the port, and I'm sure we have some Vietnam vets here. But anyway, they were still using them. After the war, they were very popularly used in King County, Illinois, in Port Chicago. They used it for a lot. These got released to civil defense organizations and used in flood. So I've got old newspaper clippings in my own town where they would use those. So way back when, and even pretty modern days, duck is still pretty useful for doing that kind of service. Most of us who do know about ducks know about them from the duck tours. Closest one to us, where I live in Northwest Illinois, is the Army ducks up in the Dells. Guy in the late 40s from Milwaukee went out to California because he heard he had a trucking company, heard they're auctioning off trucks. Well, he's going to go out there and get him a couple trucks cheap. Well, he went out there, well, they were ducks. Well, he ended up buying one just because he didn't want to waste the trip, brought it back, and he started goofing around with his friends out in Lake Michigan, and somebody said, you know, they got boat tours up in Wisconsin Dells, I think you should make some money off of that. So he took the thing up to Wisconsin Dells, and they have a huge fleet. They have over 40 ducks up there, which they give tours, and we try to make it up there every year. Since mine is not in the water yet, to do that. Some of the current tours, Wisconsin Dells, Boston, Chattanooga. There were a lot of other duck tours, but here starting about 10 years ago, there were some accidents with ducks, and it started becoming really hard to get insurance to all passengers for hire. So the Chicago, Branson, Washington, D.C., those have all, and I've been on a lot of these before they went out of business. It's important to note that a lot of the ducks that sank weren't ducks. They were a conglomeration of different things. This, to a casual observer, looks like a duck. This was never a duck. This is a newly produced thing. You see that the design features on it, this is all different headlights built into it. So that's not a duck. That's certainly not a duck, even though they call it a duck tour. That's not a duck. That, okay, well, that is a duck. So there was a couple of the casualties, notably the Miss Majestic in Arkansas with the 13 deaths. They are all, in my opinion, and in the Coast Guard's opinion, were poor maintenance. A lot of these tour companies, to get extra weight capacity, remember that Higgins pump, 350 ounce minute? They take them out. So they got extra weight capacity. And they'll put in a couple of little bitty electric bilge pumps just to be water at the end of the day. So if there's a problem of missing one of those drive shaft boots that'll let quite a bit of water in, you have to wait for the water out. There's a couple pictures of my duck. This was one of the second civilian owner of it. The guy I bought it from bought it in the mid-60s and drove it home from Fort Leonard Wood, Missouri. So this was a picture of mine in like 1966. This is when I found it in a barn down north of Peoria, Illinois. And this was on its way home. I don't have any pictures of it. My shop is such that I can't get far enough back from it. But I promise it will be here next year. Yes? Why?
When?
Oh, when? I had this one about 3 years. About 3 years. This is actually my second duck. I bought one 20 years ago.
Something like that, at least. Probably more.
It came down to where the body was just, I want a duck that I can swim. And the body was just, every time you dig into it, it was too far gone. This one here is like the most pristine sheet metal of any of the ducks in the States right now. So I was really lucky to stumble on this. But I got rid of the other one, didn't think I'd ever have one again, and then a couple years later, this one came about. Believe it or not, my wife was the one who pointed out the ad. She should have known better.
I imagine it's an expensive hobby.
It is an expensive hobby. The advantage of it is that 80% of the parts on the duck also fit that CCKW that they made almost 1 million of. So you can find the stuff. It's the best part of the hobby is finding stuff. I've got a CCKW truck out behind the shop that I use for pulling parts off of. And just like anything else, of course, I'm retired, so I got a lot of time and no money, so we just learned to do everything and try to get another wheel.
Was the transmission GM or?
It's a Clark, yeah. 204 VL. I've got some of the data plates here in the back and the maintenance order, which is worthy of pointing out. One of the disadvantages of having a duck. This is your routine maintenance lubrication order.
Wow.
There's like 22 universal joints in the duck, and this you got to go through both of these. You know, every time you take it in the water. So there's a lot of things to grease, and a lot of things to put oil on, and all sorts of things. So they're very maintenance intensive.
You have to grease it each time you take it out of the water then, make sure the water got in.
There's the only thing you really have to do, because all of the greasable things are really in a dry area. The drive shafts run in a tube that are sealed, so the drive shafts are dry. But a lot of this is based on the fact that they were running in salt water with water splashing over the top, everything getting salt water on it. A lot of the tour companies in that, they'll grease them once a month, and they're running 10, 12 tours a day out of them. So they're not quite so bad when you're working with us. Yes, it is.
See the slide at the beginning where it talks about the naming system for the.
Yeah.
Is the Army, did they get a replacement
not really. They tried a couple of, and I don't have a slide on it, but after the war, they had a couple iterations of bigger ones. There was one called a Drake, and one called a Drake, and then there's some great big huge ones, but the Duck was the last one that would be road legal today, because this is road legal, it's right width and everything, you can take it on the road. The ones that they tried to replace it with were all just way too big, and you could use them on the beach and that, but they never made many of it. They were just kind of all prototypes. And what really replaced the Duck